actually make what you like and what is useful for you. You can contact me on GitHub or on Twitter. I have a blog where most of my code is and all the demos are, and of course also all the code is available afterwards on my GitHub. I run a show, the A Bit of AI show, where I talk with guests from all over the world about careers in AI. And in that show we find out that you don't necessarily have to have a PhD to work in the field of AI. There are so many roles and so many things you can do to actually get a AI model, machine learning model from the data all the way to production. So we need like AI engineers, we need people that run operations because the model has to run. We have data engineers that will create the data. Someone actually has to sell the AI to the client. So we have salespeople we need, and we have, of course, project managers that need to make sure everyone works together. So in that show, A Bit of AI, we talk with all those different people from all that different fields about what they are actually doing and how their life in AI is, and find which education and which courses they follow to start doing that. So a little bit about me. I'm a developer and I developed a lot of software. So you can place me in kind of the thing where I know how to run models, and I know how to run them on scale and apply DevOps practices to that whole process. And that is what I'm going to talk to you today about, is how you can bring a model from basically only data all the way up to a highly scalable endpoint in Azure, so you can actually use that model in production. So we will start with a small Lego dataset that I have made. Now, actually not me, but most of my children had a camera, and they made a lot of photos of all my Lego figures. And we're going to see how that data set is going to be used to build this PyTorch model, using GitHub Actions, using Azure Machine Learning, using the PyTorch framework, using some event grid, some GitHub Actions, and then it will finally run in a managed, highly scalable endpoint in Azure. And then what it will do eventually is it will give back that little piece of JSON telling which Lego figure it is going to see. So it will be a live demo throughout the whole presentation, so let's hope it all works. So, but before we start, who has seen the presentation from Laurent before me in this room? 3, 4, of course in the back. So yeah, that is really handy, because then you have like the basic foundation of what machine learning is. I'm not going to talk about math. I'm definitely not going to talk about that. I'm going to talk to you about how you can use it. But before we start, I want to talk a little bit about some of the words and terms, so you have like a general idea when you talk to other people in the field and about this presentation, about where we are and what kind of things we use. So first we start with the term machine learning. So I always explain machine learning as giving your computer the ability to learn things without explicitly programming it. And for the others that were in Laurent's presentation, you have seen these slides. We use that all over our team. So we start in the old days, or when I was developing a lot of things, I started with a function, an algorithm, like a lot of if, then, else statements. And I run data through it, and I would get like an answer. So 1 + 1 is 2. So basically I've written a function there, and it does what it does. With machine learning, that is a little bit switched. So I give it a bunch of data, in this case a lot of Simpson images. I tell it which Simpson images it are, and the machine learning algorithm, in our case PyTorch, will create this algorithm for me. Or, in machine learning terms, it is called a model. And when we have that model, we can run new data through it, and it will give us a prediction. So it will not tell us like, hey, I'm 100% sure that this is Homer, or this is Wonder Woman, or anything. It will tell us, I'm like 90% sure that this is Homer Simpson. So it always does an educated guess. Then a little bit further, what is deep learning? So first we have to understand what we actually mean with AI, with artificial intelligence. So artificial intelligence is like kind of the thing that computers pretend or try to simulate or mimic human intelligence. So someone that is actually talking to a computer or a human doesn't really seem notices the difference between those two. And to do that, we can use machine learning. But if you're smart, you can also do like a very big if-then-else construction to actually make that happen. So machine learning is a subset of AI that will help you to do that easily. And deep learning is again a subset of that. And how does it work? For me, I didn't study all that algebra and all those machine learning algorithms. So how I like to understand it is that it's starting to learn things while it is training the model. So first, it will probably start to recognize some shapes. Then it will learn more, then it probably start to recognize, if you train it on faces, it will recognize some eyes, and more and more and more and more details. So what we are going to use is a transfer learning script, because I'm not going to train the model from scratch, because that takes a lot of time to train. So what I'm going to do is I'm going to build on top of somebody else's model. So basically see, like, you copy some code from Stack Overflow, you get it here, and you start building on top of that and build your own algorithm. So that is what I'm going to do. I'm going to gain the knowledge, or use the knowledge that is already gained by that model, and put and add some extra images to it, so it will start recognizing my Simpsons models. We're going to do that with computer vision. So computer vision is a field in the artificial intelligence world that trains computers to understand the visual world. So you give it a bunch of images, deep learning algorithm, and the machines are going to detect and classify what is there on those images. And there are basically 4 types of things you can train. So classification, you just give it an image of like one single thing, and it will tell you, I see a cat. You can have, and that is like the easiest thing to train. That is also what we are going to do, because we don't want to sit and see my computer train for like a few hours. So that is the easiest thing to do, but you need also to understand, if you have 5 cats on it and a dog, it kind of not really understands it. Then it can do classification and localization. It's still one single image, but it will tell you there is the cat. We have object detection, then it will tell, like, there is a cat and a dog there. And then the final one is it can actually tell them very accurately where they are. We're going to use the PyTorch framework for it. So PyTorch is an open source machine learning framework based on the Torch library that was actually written in Lua, used for application as mostly computer vision and natural language processing, and is created and open sourced by Facebook AI Research Lab, which I think I have to update to Meta AI Research Lab. So let's take a look at a small demo how I can train a classification model on my laptop. So we'll hope it will not go up in flames, but we will have a look and see how you can quickly prototype some of your code. So here I have a Jupyter notebook. The real cool thing from the Jupyter notebooks is you have cells, you put in some code, there is a play button, it runs that code, and all the variables you have in there you can use in other cells. It can be a bit confusing because you can do some variables here and then use them later up in other cells, but if you're doing it right, it is really awesome. So this is an example Jupyter notebook I've downloaded from the PyTorch website. You can just download the notebook here, and then you have the notebook. And that is what you see here. I adjusted it a little bit so it will work for my problem. So let's run all the cells, because the training takes a little bit of time. So let's go through this notebook. So we start with a lot of importing a lot of dependencies. You have to install PyTorch on your laptop to run it, and of course Python. Then we're going to see if we are going to use a GPU-enabled training or a CPU-enabled training. I don't have a GPU in my laptop here, so it is going to use a CPU instead. Then we're going to load in the data. All the data is being scaled to 224 pixels. And it is found in this data folder. If you look at the data folder, I have 3 directories. I have a training directory, I have a validation set, and I have my own test set. So the training set is the data that is being used to train the model. Validation data is used to validate the model. And the test set is just my test set, which I'll run through the model to actually see if it is doing the thing I want it to do. For this example, for this PyTorch example, you just need to put them in directories, and I have around 50 images for each of my Lego figures. And it was quite hard to take 50 photos of every small Lego figure. So what I did is I looked at a lot of different backgrounds, a lot of different positions from top, from bottom, but also the background. So it was not, so I was not training a model that was not recognizing my Lego, but was recognizing the background. So I have that, then I can visualize it. These are the images, like from top, from the front, and then I'm training the model. We're just going to go through the model. Here we load the pre-trained model. This is a ResNet 18 model. We load that, we download it. It is all built into PyTorch, so that is really great. Just with one line you get that model. And then we train the model. So I'm doing one training round because that took 15 seconds. We could have done more, but the problem is so simple that it is doing quite a good job on it. So we're training the model, and then we're finally going to show it. And here we see that it has trained it. This is Homer, March, Homer, 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 March. So this is how that notebook looks and how kind of simple it is to pick up some code and train a model locally on your machine. But now it is on my machine. And I don't know how many of you are developers, but it kind of always scares me that these things are on someone's machine and not in version control. There is no build server. Which version of PyTorch am I running? And so on. Does it also work on your machine, and do we get the same results? So in the next part of the presentation, we're going to look at how we can actually operationalize this model of this thing. So again, this is what we're going to build. We now kind of have this part here. We have a general idea about our PyTorch script, about how we want to create our model. So now we have to do all the other things. And we only use like a little subset of the data to train it, and not like the 50 classes I have, because that will take a long time on a CPU. So the big question, how can Azure Machine Learning help to bring this model to production? And then we have to start looking at these kind of challenges we might have when you're training these models. So we have to think about dependencies. We're probably going to use some containers to train these models in and to run them in. We have to think, what are we going to do with something fails? How can we secure access so that nobody is going to steal our model and our data? How are we going to do distributed training? Because with PyTorch you can do distributed training. How are we going to scale resources, and how are we going to provide provision clusters of virtual machines that are for everyone to use, like in a same shared environment? So a lot of questions that we need to take care of. And the good answer is Azure Machine Learning will help you, of course, with all of them. So what is Azure Machine Learning? The term is kind of maybe a little bit confusing. So Azure Machine Learning is actually a product, if you look from the Azure side. And it is a service that helps you work together as a team on your machine learning workloads. So what is it? It is a set of Azure Cloud Services that you can control using a Python SDK, and you can interact with using the Azure Machine Learning Studio or any interface of your choice, including like from Jupyter Notebooks, from a visual designer, from using automated machine learning, CLI, the client line interface, so you can just type like cool commands to it, and you can use it in Visual Studio Code if you prefer that IDE. And it enables us to commonly prepare data, build models, train models, and deploy our models in one single service everyone can use. And these are some of the key elements of Azure Machine Learning. So we have models, the place where we store all our models. We have experiments, there we keep track of all our training runs. We have a place to manage our environments. We have a place where we can store our data or connect to our data. There is a cool data labeling tool, and there is a function called pipelines where we can create actual pipelines for our machine learning models to train. And this is how it looks. You go to ml.azure.com, you get this pretty clean looking interface, and you will find all the things back that I just talked about, like data sets, experiments, pipelines, environments, models, and here is your compute. So let's drill in a little bit deeper about how it actually works underwater. So I always try to look at the machine learning problem in three ways, or in three parts. First, we have to handle data, then we need to train, and then we need to deploy and run it in production. So, Azure Machine Learning. If we're talking about data, everything is surrounded or tied to a data set. So my Simpsons data set would be the base of where we're going to train the model from. The data set is being located on a data store. In my case, I've uploaded it to a blob storage. But the data set can also connect to SQL servers, data lakes, basically anything that can hold data in Azure. And then to enrich our data, your data set, there is the data labeling tool if you need to label and actually make training data for your object detection, like here is the Lego figure, here's the bird, here is the cat, if you have to do that. Then there are multiple ways to interact with Azure Machine Learning. So there is automated machine learning. We'll dive into a few demos about that later. So there's automated machine learning. There is a visual designer. There you can drag and drop components and create a visual pipeline. There is an SDK that you can use from Jupyter Notebooks, from regular Python files, or your CLI. And there is something called pipelines. You can build those pipelines, publish them, and then you can kick them off over and over and over again to retrain your model. But all those things come down to the same kind of concept. They create a run in Azure Machine Learning. And that run is grouped under an experiment. So an experiment can have a lot of runs. And the good thing about that is that you can compare those different runs with each other. So if you save to your metrics in Azure Machine Learning, you can actually see, oh, if I use this parameter, the accuracy goes lower. So I probably want to tweak that. So every run starts with the training script. That is the thing we saw in the previous demo, the PyTorch file that will generate your model. The training script needs to run somewhere. So it needs to have some environment where it can actually execute the training script. There are two types of environments available in Azure Machine Learning. There are curated environments. They are managed by Microsoft. They have like a PyTorch version 10, optimized for GPU, running on Ubuntu with all the Azure libraries installed already. So you can pick them out. You can always use the latest version or specify a very specific version. Or you can create your own environment, either from scratch, so bring your own Docker container, or you can start with the minimal image and build on top of that. those environments with your training script have to run on some type of compute, because Azure Machine Learning basically is just a thing in Azure with configuration. So you need compute for that. And that compute can be a few things. So there are Azure Machine Learning clusters. These are scalable clusters consisting of machines with ranging from like 1 GPU up to like 32 GPUs. And like a few hundred cores, a lot of memory, or like the smallest one we are going to use, they have 1 GPU and like 56 gigabytes of memory in it. There are Azure Machine Learning instances. An instance is just a single piece of compute which you can use to kind of prototype things, run your notebooks on, or train a very small model. There is local compute, because the SDK enables you to test and run your things locally, so you don't have to submit it all the way to your cluster, but you still have the benefit that it streams all your metrics and logging to your Azure Machine Learning run that is stored in your workspace. Your training script can connect to the dataset. Azure Machine Learning will automatically inject that data store as a virtual directory in that container. And then your training script will start creating artifacts. It will generate a lot of logging, a lot of log files, and eventually it will create your model. And that model you can register in a service called model management. So you have the model and you register it there. And then I always compare model management like with kind of the NuGet repository for your models. So someone builds this thing, it is done, it is nice, it is tested, because that is the responsibility of this process. So you publish your model there, and everyone can kind of connect to that model management system and picks out the model. And the model basically are two files, a labels file in our case, and a model file. So they can pick it out and start building software around it, because that model file doesn't do that much without software that runs it. So when the model is there, we can use Azure Machine Learning to start and create deployments. You don't have to. You can just pick out the model and put it wherever you want, run it in your own infrastructure. Doesn't matter, it is there. But you can use Azure Machine Learning to accelerate that deployment. So for the deployment, you need a scoring script. The scoring script loads in the model, handles the incoming data, and returns the result for you. And you need a deployment configuration, like how many CPUs, GPUs, memory does this deployment need, and how does it have to run, in which environment. Mostly you use like different environments for your training and for your inference, but they're all stored in the same part of Azure Machine Learning. So your deployment, so your environment is there. So then you have to choose your target. It can be deployed in an Azure Kubernetes service, in an Azure Container Instance, if you just want to test some model. You can deploy it in an online endpoint. These are the new things that are still in preview, but they're really cool. I will show you them later. Or you can use it in a batch endpoint if you want to process lots of data and you don't need the model to be available from the outside world. So there are three ways of training your model in Azure Machine Learning. All code, which I like. Absolutely no code. Automated machine learning will handle basically everything for you all the way up to the deployment. Or like a little bit of code that you create machine learning pipelines using the Machine Learning Designer. So let's have a look at what automated machine learning is. So automated machine learning will figure out the best algorithm for your problem. So you give it a data set, you define this is the cell I'm trying to predict, and it will run it through all these different types of algorithms for you. And it will tell you, hey, I think this algorithm is the best fit for your problem. So what it does underwater, it is just generating like a bunch of runs and compares the output of that model. And then you can pick the best model and deploy it to an Azure Container Instance or to an Azure Online endpoint. The Azure Machine Learning Designer is very small, sorry for that. You have like modules on one side. You can drag them on here and connect them to each other, so they will give out the output. So you drag on your data set, you drag on your training algorithm, you draw an arrow between them, and it will pass your data set to that component, and then to the next and to the next. So that is a visual way of doing things. And then finally there is the option all code, and there you can use you can type it in Python from a Jupyter notebook. You can use the Azure CLI with YAML configuration files to control Azure Machine Learning. And that is what we are later on going to look at. So let's have a look at automated machine learning in Azure Machine Learning. So I'm going to go to automated machine learning here. So I click new automated machine learning run. Then it asks me, hey, which data set do you want to use? So I went to Kaggle and I downloaded a second-hand car sales data for Audis. So I can click on the data set. It will kind of open it for me. And here we see what is in it. It's just a CSV file with like models, the A1, the price that is being sold, the mileage on it, if it is petrol, and the engine size. So basically that. So I'm going to use that data set. Next, it will ask me under which experiment do you want to generate these training runs. So I'm going to select, let's do my used cars experiment. I'm going to select the column I want to have predicted. In this case, I want to have the price. So I want to have an API that I say, like, this is the A1, this is 15,000 miles, it runs on petrol. What price should I ask for that? I'm going to select my compute cluster. I have a compute cluster called Bumblebee that consists of standard NDC 6 machine, NVIDIA compute with 6 cores. That's where it stands for. There's one GPU, the Tesla K80, I think, 56 gigabytes of memory, and it costs around €1.17 an hour. So the good thing is for your clusters that they will scale down if you don't use them. So you only pay for the compute when your cluster is up. You can have your cluster up and running all the time. That's what I have done now, because it takes around 10 minutes for a cluster to be kind of provisioned and ready to go, and we don't want to wait for that. But if you're doing it at your work, the cluster will scale down after the amount of seconds you give in. So by default, it's like 3 minutes. If there is for 3 minutes nothing to do, it will scale down. But this cluster is up, and click next, and I select the task it has to do. So this is a regression problem to predict continuous numeric values. I can click next, and then I have to click finish, which I'm not going to do because the training run takes 20 minutes. And then when you click finish, it will start to run and will spin up all these different runs with all these different algorithms. So we can look at the previous experiment that I run, auto price test, and we can see it here. Click on here. So when the run is done, it gives you kind of this overview. I have to tell you, hey, the best model summary, the best algorithm that I found is apparently this one. Took 23 minutes to figure it out. It used this data set. And it generated all these models. So you also have all the other models that are generated by the automated machine learning runs. So you can also run and try them out on real world data. All your logging is available here. You can actually see the scripts it runs, and here are all the runs, the child runs that were there. So now we have a model here, basically this one, or that is this algorithm name, and now we can start and deploy this model by just a few clicks. We can choose if we want to deploy it to a real-time endpoint. We'll talk about these endpoints a little bit later, but you can also deploy it to a web service, and that goes very quickly. You just give it a name, a description, and select your compute target. So it can be a linked Azure Kubernetes service, or it can be an Azure container instance that it will just create and build for you. And you can enable authentication or not. So this takes around 5 minutes to create the Azure container instance. So I'm not going to let you wait for that, so I've already done that. So the endpoints you can find back under endpoints. So here we see my Audi price prediction endpoint. This running here, I can here see how to consume it. So if you would send JSON to this endpoint, you would get a prediction about your car. So we can test it here. This is the input data it needs. It will just create this sample for you. But I have already filled that in. I can say test, and here we get back, okay, for this model, for the A5 2020, you should ask around 14,000 euros. So this is how you can do something with automated machine learning. The visual design, that is also really cool if you just want to get started with Azure Machine Learning. So we can create a new pipeline, but you can also choose for one of the examples to see how everything works. So we're going to start from 0. And we're going to, first they ask to select us our compute cluster. We're going to use the same compute cluster here, pipeline, where the data is going to be all good. So we're going to start with data sets. I'm going to use my Simpsons Lego dataset. I've created some custom components here. This one will train a PyTorch model. This is basically the component I created where that same PyTorch script is in that we saw and downloaded from the PyTorch website. And then I have a step that will register our model. I will tell it where the model is, where the labels file is. Here I can tweak some of the parameters. So I say like 2 training rounds is enough. And let's, Simpsons classification, let's call it like this. So I can submit it. Then it asks me which experiment we have want to run it. So let's call this NDC. And we say submit. And if we're lucky and my cluster is there, it will start training immediately. So it is now preparing this whole run configuration for me all in the background. And then it should start picking out the training environments and all the things that are in the background configured in these modules. And start deploying it to my cluster and start running it. So we see that it actually started running. We'll try to make some more space here. And we should be seeing, if it actually starts running, we should be seeing some metrics in here, like how the training is actually going. Here we have the parameters, output settings. You can do it right click. So here we can find all the logging. So the cool thing is that all the logging, everything that it is doing, it is centrally stored in Azure Machine Learning. So you never have to worry that any logging or anything about your, well, it's even finalizing and not giving an error. So it should give us some metrics. Excellent. I'm going to zoom out a little bit because this is quite... So here we see that it is done a graph for the accuracy and the training loss. We only did like 2 runs to speed it up a little bit, with 2 epochs. So we see the validation loss. So if you use run.log in your code, then automatically every metric you want you can push to Azure Machine Learning. So now the final thing it will be doing is registering the model in model management. So when that is done, we should be able to see our model here under model management. And I'm not impatient at all, because it's spinning up a new container that deploys it again to Azure Machine Learning. So the model should be appearing somewhere here soon. Pipeline is still running. You can do it. The training went very fast. So in the next steps, we are going to see how we can build exactly this same pipeline, but then with from all the way from code and using GitHub for that. Okay, when we are back, we will see if the model is registered. So now let's talk how we can bring our Lego model really to production. So we've seen now some ways to generate runs. I hope everyone understands like kind of the concept about what Azure Machine Learning, how Azure Machine Learning is working underwater. So we are going to apply some DevOps practices to this whole machine learning problem. So because DevOps is the union of people, processes, and products to enable a continuous delivery of value to our users. And that goes for software, but it absolutely also goes for machine learning models. Because who doesn't want to deliver value to their end users with a very good model? So a reminder for myself to actually start the process of training the model. So I'm going to do that from a code space. I have to restart it because code spaces shut themselves down to save money, which is a really cool thing, but not during a demo. So we boot up this code space, and we're going to work in that code space and push code to GitHub. Luckily, they boot up pretty fast. So I will talk to you all about what this code is going to do, but the only thing I'm going to change here now for our pipeline is that we're going to use the Lego figures small data set. I'm going to double check the name. Can load in the file today, please. And it is called the right way in the pipeline. Yes, I typed it right. We're going to change a little bit of code here in the train.py. We're going to say use like 5. We're going to commit these changes, NDC Porto. Yes, add everything, please. And we're going to push this to GitHub. So now a GitHub action will go off. I'll build this whole pipeline for me, but the creating the pipeline and running the pipeline and finally deploying takes around 15 minutes. So we don't want to wait for that. So I'll start with the pipeline. So let's take a look at an ML Ops or DevOps workflow from the eyes of 2 personas. So we have the Azure App Developer, that's the one that's going to create software around the model. We'll work in GitHub, we'll build an application, test the application, release it, starts monitoring if it is actually performant, and then feed that back to do better next time. That's the same thing as a data scientist using Azure Machine Learning will do. It will work in a GitHub repository because we need to have all the code in GitHub and not on local laptops. But then instead of building the app, it will train the model, to validate the model, help deploy the model, and learn from how the model runs in production, and brings that back to the training stage. How does our machine learning lifecycle look for our model, for our problem. What are we going to? We're first going to do some data preparation. We're going to upload the data to a blob storage, create a data set from it. We're going to do some model building using PyTorch, Python, in a GitHub code space, like we just saw. Then we're going to do some model training. We're going to use a code-first pipeline. So no visual interface, no clicking next, next, next. Using a PyTorch training environment. Run it on an Azure Machine Learning cluster, compute cluster. And using a GitHub action to kick off the training and build the pipeline for us. Then we register our model in the pipeline. So our pipeline is going to deliver a model in model management. And then we're going to use another GitHub action that is going to deploy our model. So back to this nice circle diagram that took me a long time to make. We're going to use a data set, have a training script, using a pipeline, using an Azure Machine Learning compute cluster, use a curated environment, an environment that I made, register a model in model management, create a deployment, and deploy that in an online endpoint. So let's go back to the demo. No, not yet, sorry. Let's first talk about machine learning pipelines. What are machine learning pipelines? So machine learning pipelines are a workflow of steps we already saw in the designer interface. There are all kinds of steps, and those steps are connected. And they can use data sources, data sets, and can run on compute targets. So they can actually run on different compute targets. So you can have like a CPU cluster and a GPU cluster. So step 1 will use a GPU cluster, step 2 will use a CPU cluster, and they can pass the output through to each other. So this is like kind of the basic of one of a component. So it runs a script on a compute target in an environment which is basically a Docker file. It can take input, generates output, and it can take like parameters in. And this is how it looks in a YAML configuration file. So you can control Azure Machine Learning using the Python SDK. You can do that from a Jupyter notebook, you can write it in scripts. But in the new update that is now in preview, they kind of separated those things because they thought it would be better to kind of have the training script like as a training script and have the configuration about how your training script has to run in configuration files. And they chose YAML for that configuration files. Those configuration files you can kick off and run using the Azure CLI, so the Azure Command Line Interface. You install an extension, the machine learning extension, and you give them these type of files. You saw Azure Machine Learning, Azure AZ ML, and then the commands you want. So like if you want to have a data set, or you want to create compute, or you want to create, in this case, a component, you say AZ ML component -- file, and then you give it this file. It uses the underlying authentication to Azure. And you have to specify, of course, your subscription and your workspace ID. And your credentials need to have access, of course, to that resource. So what am I doing here? I'm creating a component that is called Train PyTorch Model. This is actually the component we used in the visual interface, which I've created using YAML. Here are my inputs. I just specify like this is an integer, the default values, the output. So everything my script generates you put in this path. You can find the code here. This is a local file in my GitHub, of a local directory in my GitHub. And you can use this environment to do this. So this is a curated environment. And if you have the Visual Studio Code plugin installed, it will nicely autocomplete this all for you if you have the right schema there. And then you just specify the command it has to run. So you say Python train and then specify the data and input. So back, okay. So this kind of refers to this. Output refers to outputs. So a pipeline is a combination of these steps. So we start off with a data set, we start with, then we train our model, we have a model that's passed on to the register model step, exactly what we saw in that pipeline, and then finally it is registered in model management. And the pipeline is another YAML configuration file. So you will end up with a repository with a lot of YAML configuration files and a lot of Python script that the Python scripts actually do the work, and the YAML files have the configuration in it. So here we have it. We have the inputs, the starting inputs that will pass to the training job. The training job has output, it uploads it, and we pass it on to the register model job. And this is a very, very simplified pipeline because nobody would only have like 2 steps. But this is just to illustrate how things can work. So now we can actually go to the model creation here. So let's see if the pipeline actually started. Going to pipelines and see that our pipeline is luckily running. So we have seen, here's the GitHub code space. So we have seen the pipeline. But how am I running this in GitHub Actions? So I have here a GitHub action that is actually going to create this pipeline for me. So I have a secret in Azure GitHub so that it can connect, the action can connect to my subscription. So I've created an Azure Service Principal for that. I'm telling which resource and which Azure Machine Learning workspace it has to use. And then it checks out my repository and it just starts running these CLI comments for me. So I said AZ, set the default configuration for me, because then I don't have to type it after every CLI step. I don't have to type like, this is my workspace, this is my resource group, this is my subscription. So I can set some defaults. And then I'm saying, okay, create my environment, create my compute, and create the actual pipeline. And when a pipeline is created, it kind of automatically starts running afterwards. So this is what it does. So you see that a pipeline takes around 10, 15 minutes, half an hour. If you have a really big thing, it can take days. So the thing you don't want is that your GitHub action is going to wait for your pipeline to be finished to kick off the next one, because it will burn out your GitHub actions. So this action will just kick off the pipeline, and then this action is done. So let's have a quick look at the compute. So what this does is make sure that this compute cluster exists. So and this is also how easy it is to create a compute cluster. It creates an environment based on this environment, and I can use it as a Lego PyTorch, which I can use in my pipelines components. There's so many YAML files. Here as the preferred environment. So you can overrule this again in your master pipeline to make it even more complicated. So let's talk about model deployment as the final stage. So how do you choose your inference target? So this is I actually found it in a marketing slide, but it was very, very useful to go to this tree and choose which type of inference target you have to use. So it's the first time you're going to deploy this model. Yeah, so try it out locally first. For us, no, absolutely not, of course. We're going to want to have it in production, and we want to have low latency and high throughput. So low latency, high throughput. If we need high throughput, then we can use batch inference that will just do it underwater, like extremely very fast without any interface to the internet. But low latency and minimal costs, high availability. So we want to have a cluster. We don't want to have one Azure container instance that when a new model is deployed, it will just go down for like 5 minutes. So we end up using an Azure Machine Learning online endpoint. So what are online endpoints? They're very, very much in preview. So the recommendation is not to use them in production yet, but if you're now building something, I would kind of explore this option. It will really save you all the time of setting up this Azure Kubernetes services and all the overhead of managing and updating your Azure Kubernetes service. So what this online endpoint does is, so you create this online endpoint, and in that online endpoint you can create deployments. So every time you have a new model, you can deploy that in your endpoint. And then there is a routing mechanism that say, okay, send 90% of the traffic to that endpoint and 10% traffic to the other endpoint, to the other deployment. So you can actually see if your new model in the real world is performing better than the other one. You can also choose different types of compute for your models. So you can have a deployment like on CPUs and GPUs and kind of compare them if you route 50% to that, 50% to that. So that is really cool. So there is also inbuilt authentication in front. You can test all the deployments individually, and an individual deployment has auto-scaling in it. So it runs, for instance, on one NC6 machine. If the load is around 60 to 70%, it is just going to scale up automatically for you until the number of compute you have given it. It will not scale up to 1,000 automatically for you. You have to say like, oh, you can use like 5 or 6 of these extra compute targets. But how do I get this deployment actually to run from GitHub Actions? So Azure Machine Learning generates events when things happen, and they put it on the general event grid, which is being used in Azure. So when my pipeline is done, a model is registered. Then when that model is registered, it will create a message in event grid saying model is registered. And for that, with that event, you can create a logic app, a GitHub action. You can basically do whatever you want with that event. I wrote a logic app that kicks off another GitHub action to actually start the deployment. So what does it do? It looks if there are messages in a queue. So first thing I do is pick off the message from event grid and put it in a queue, in an Azure Storage queue, because then I actually have like retrying. If my logic app fails, the message comes back in the queue and I can replay it and redo it. So I have an Azure queue in there. I parse the JSON that it generates. I look what event type it is. If the event type is machine learning service model registered, I check if it is the right model, if it is actually the model, because there can be like so many models registered. So if it is the right model, then if it is the right model, I just kick off another GitHub action with a REST call. So you have a personal access token for GitHub. It is here in this step. So it uses that to kick off the GitHub action that will start the deployment. And because there are a lot of other events, you can build on top of that when there is a deployment. Oh, start running these test scripts against that deployment and start auto-scaling the endpoint. Move all the traffic over automatically if the model performs well. So the last piece of the demo, and then it is absolutely time for lunch. So here we have the deployment. So it's just basically one script that will tell like, hey, use application insight. This is the model name you want to use. This is the scoring script. This is the environment. And here you see I have a specific pre-built inference environment. My compute, I can basically choose all the compute that is available in Azure in your region. And my instance count is just 1. I have the deployment model pipeline here. That will again log into but here you see that it's a repository dispatch action and not an action like in here that it is triggered on a push on a branch. I have my workspace here. I check out again. I replace some variables in my YAML because you can't say model.latest. At that moment when I'm writing my YAML files, I don't know which version of the model is going to be deployed. So for now, you have to just replace those variables. with this Unix Linux line. I'm adding the Azure Machine Learning extension to the CLI, and I say Azure Machine Learning online deployment, create one. So now the big question would be, is this GitHub action already triggered, or is the model still training? Because I would love it if the model is deployed. So here we should see the GitHub action of the logic apps that are being triggered. So this was, you can show something at least, yeah. So this was a modeled registered action. So it should be like 6-7 minutes ago it was triggered. So we can see under endpoints if our model is being deployed here. So here we see model version 14. That is our model. You have to trust me about that. Where is it going? Real-time endpoints classification. Because the model from this morning was 100%, and the new one, version 14, is being deployed. There are no dates and times, but this one is the one being deployed. So what we can do now is we can use, again, the Azure CLI to change the traffic, but we can also just say, oh, now route all the traffic here. So this is a small model. So I want to close off with running a Jupyter Notebook against the endpoint I already trained. That was on the big data set, and this is trained on the small data set. So these are all the test images I'm going to throw against the endpoint. So it is sending all these links with images to our online endpoint in a nice JSON format, and then it will draw this for us. And here we see that this endpoint can actually classify all these Lego figures. So here we have Star Wars Yoda, we have Wonder Woman, and we have Stargirl. So to show you that our endpoint is actually doing it, you have a test piece here. So now we are going to test against endpoint 14. So we trained on a very small subset of the data, which were in our data. I forgot. We trained on Wonder Woman and Batman. So let's send it to, where is it? Here. You have to type the JSON here. Say test. It can classify Wonder Woman. This is the model that it's running 14, but it should not be able to classify March. March is with lower, of course, and it classifies it as Lisa. But if we go back to our bigger model, this is trained on the complete data set. So this one can actually classify March. So to close off, 1 minute too late. We have created GitHub action that can create a trainings pipeline using a Simpsons dataset that kind of registered the model, that triggered events in Event Grid, add messages to our queue, started the logic app, kicked off another GitHub action that started the deployment of an online endpoint. And now we can actually start sending images to that highly scalable endpoint that is in Azure. So thank you so much for sticking with me for this full hour. And if you want to do this, all the code, the whole GitHub repository is available on that link. So you should be able to build that for yourself. So thank you everyone, and enjoy your lunch.